In this lesson, we're transforming functions. We're on transformations. And this is exactly what it sounds like, you guys. We're changing the graph, just like Optimus Prime here, right? And because of where I've chosen to put this lesson, you're already familiar with all the key ideas, right? So we're just going to formalize things a little bit. But you're already familiar with how these things work. So considering my first problem here, I have a function f of x that is linear, representing my wage in dollars after X hours of work. So pretty relatable situation, right? And we want a transformation that's going to represent a $50 tax cut. And we're going to investigate this graphically, and we're going to make it a little bit more formal a little bit later here. So if I just sketch my graph f of x, I don't have to be super precise about it, but I should have a negative y-intercept, and I should have an increasing slope based on the function I was given. And you guys are wise enough to know that a tax cut means an increase in my pay, right? So the way I'm going to represent that is by shifting my graph upwards, right? So no matter how many hours I work, I'm making more money, a little bit more money than I was before, which is nice. So the way I represent that, right, is if I have f of x before, my transformation, well, is f of x plus flat $50. And this type of transformation, by the way, is called a vertical translation. And that just means we shifted our curve upwards. And let's go ahead and label these before we move on. So f of x plus 50 was our new curve in blue, and our original curve was f of x in green. Okay, so that's a vertical translation. We're going to see this again here when we consider our next problem, which is we're given f of x again, and that's a parabola in vertex form, so it should be familiar from Algebra 2. And g of x is f of x translated, that just means moved, as we saw in the last one, right? Left 5 units and down 2 units. So I'm going to start by drawing f of x, and again, I'm just sketching. So f of x has a vertex at 2, negative 4, and that comes from the function, right? And remember, my x-coordinate of my vertex is negative from what it is in the function. That's a property of vertex form. So I'm just going to sketch a parabola right there. So 2, negative 4 would be down here, and I know it's a happy parabola. And then g is translated 5 units to the left. That means 5 units to the left of 2 is negative 3. And then down 2 units, well, that's negative 6 from negative 4. So there's our vertex of g of x. So that would look something like this. It should be roughly the same parabola, just moved a little bit. Mine, again, are probably uglier than yours. Go ahead and label, though, g of x on the left, f of x on the right. So notice we have two translations happening at once. We have a horizontal and a vertical translation. So let's try to write down my formula for g here, and leave yourself a little bit of room to the left, because we're going to use this to kind of formalize these notions of translations a little bit. So my formula for g based on my vertex, well, it would be x plus 3 squared minus 6, right, in vertex form of parabola. But let's write it down as a translation of f. So look what we did with f. So f was, well, x minus 2, I'm going to leave myself a little bit of space here, minus 4. And then my translation, where did my 5 show up? Well, my 5 is what changed my minus 2 to a plus 3. I added that in the inside. And then my 4, well, to get to negative 6, I subtracted 2 from it. And that's my down translation, right? So this is a way I can write down my translations without knowing about vertex form and without having to know about the graph so much. So pretty useful. Let's write down a rule here. So adding a outside of a function or subtracting a outside of functions, these are vertical shifts. vertical translations. And outside the function, that really means something like x squared plus a. We'll see how that's different here in a second. So notice the difference here, I want to say a units, between a horizontal and a vertical shift. So what I mean by this, by inside the function, is rather than adding a outside the square for a quadratic, it would be inside. And that's consistent with what we saw up here, right? That's a horizontal shift, horizontal translation. Okay. So where we're changing the function, what happens to the graph depends on where we're changing the function. We have one last type of transformation to consider, and these are going to be reflections. And you're already familiar with one type of reflection, which is a happy parabola versus a sad parabola. So you know, for example, if thrown a negative in front of f of x here, it would flip it upside down. Something you've known for a long time. We're going to consider that reflection and then also another reflection. And we're going to do this by looking at the graphs of h of x and the graphs of h of negative x and the graph of negative h of x. So again, we're going to sketch all three of these. I forgot to give you an xy plane, so go ahead and draw it in. And I've made all these graphs in Desmos here behind Optimus Prime, and here they are. So we'll start with just plain old square root of x. And notice we get this kind of sideways parabola thing, which kind of makes sense. We'll maybe talk about why that is a little bit later in the course. I'm going to sketch that in red and label it square root of x. And then, let's see, so negative square root of x here is in blue. And notice that is a vertical flip, vertical reflection. And that's why it's called a reflection, right? It's as if I held a mirror up to my original function to make my new function. And then, so we've done now negative h of x and plain old h of x. And then here is h of negative x. So notice that flips it now horizontally. So that's a horizontal reflection. So we're going the other way now. So our result was that h of negative x is a horizontal reflection, and negative h of x was a vertical reflection. All right, so that's our rule. Let's formalize this again. So for a function f of x, f of negative x, again that's inside the function, is a horizontal reflection. And we could say it's over the y-axis. That means the y-axis is like our mirror, right? And then negative f of x, this is our happy sad parabola, negative f of x is a vertical reflection. And again, we have this sort of inside versus outside situation.